Assalamu alaikum. This is day 2 mathematics 8th edition, chapter 7 direct and inverse proportions, and today we are going to solve practice now 6. And by solving this practice now 6, you should be able to solve exercise 7b, question number 1 till 3, question number 5 till 8, and question number 11. They all are the similar questions. Now let's read and understand the question first. If y is directly proportional to x square and y is equals to 18 when x is equals to 3, find an equation connecting x and y. So very first thing, we have to focus on this statement first, and we are going to convert this statement. Y is directly proportional to x square. So how I'm going to write this? Ki y is directly proportional to x square. We need to remove this sign of proportionality so we can convert it into the form of equation. And when we remove the sign of proportionality, we introduce a constant, and y is equals to k. Now this k is my proportionality constant that I have introduced over here. Y is equals to kx square. The thing is that we need to find the value of k. So what I'm going to do, by using these two given values, y is equals to 18 and x is equals to 3, these given values, I am going to find the value of k. So y is 18, so I'm writing 18 instead of y. K, x is equals to 3, but x has a square, so 3 will be like this. So 18 is equals to 3 3 is 3 square is 9, so 9k. This 9 is multiplying by this k. When I will move it to the other side, it will divide. So 18 divided by 9 is equals to k, and 9 ones are 9, 9 2s are 18. So k is equals to 2. Substitute it back over here, so you'll find y is equals to 2x square. This is my connecting equation, and using this equation we are going to solve the rest of the parts. In part 2, they're saying find the value of y when x is equals to 5. Using the same connecting equation, y is equals to 2x square, I'm going to substitute values. We have to find y when the value of x given over here is 5 square, because x is a square, so we'll do the squaring of 5 as well. 5 square is 25, so y is equals to 2 into 25, and 2 25s are y is equals to 50. This is the answer. Now in part 3, calculate the value of x when y is equals to 32. Using the same connecting equation that we found in part 1, y is equals to 2x square. Now I'm going to substitute the value of y over here. So 32 is equals to 2x square. This 2 is multiplying by this x square. When I will move it to the other side, it will divide, is equals to x square. X square is equals to 16. Now this is the value of x square, wherever we have to find the value of x over here. So how to get rid of this square? I am going to take the root on both sides, since root is the opposite of square. So taking root on both sides, under root x square is equals to under root 16. Root and square cancel, so since 16 is a perfect square and 16 is the square of 4 square, so it will be written as 4 over here. So the value of x is equals to 4. Now in part 4, they're saying you draw the graph of y against x square. One thing you need to understand, whatever is written after against will come on the x-axis, and whatever is written before against will come on the y-axis. So I have made an axis over here where I have mentioned x square on the x-axis and y on the other axis. So from part 1, the values that were given to us were these: y is equals to 18 and x square. Since they have asked us to draw the graph between these two, y and x square, so this is very important term. This is not a single x, this is x square. So whatever the value of x, in part 1 it was given to us this y is equals to 18 and x is equals to 3. So what will be the square of 3? 3 square is 9. So I will use the square value, okay? X square is 9 and y is equals to 18. And when I will plot it over here on the graph, like this. So this statement you have to mention that since y is directly proportional to x square, then the graph of y against x square is a straight line and that will pass through the origin. So you just have to pass this line through any one single point and you have to show this that it is passing through the origin. This is the required graph. Okay, now question number 2 of practice now 6. Question is, if y is directly proportional to x square and y is equals to 21 when x is equals to 2, find the value of y when x is equals to 4. First we are going to convert this statement. Y is directly proportional to x square, so I am going to write y is directly proportional to x square. Remove this sign of proportionality and introduce any constant. So y is equals to kx square. I am using this constant k. This is the constant of proportionality. Now we have to find the value of this constant. So we are going to use the given values to find the value of this constant. First I am going to use this value. Y is equals to 21 when x is equals to 2. So that I can find the value of the constant. So y is 21 is equals to k into x square is what? 2. 2 square. So 2 square is 4. So 21 is equals to 4. This 4 is multiplying over here. When I will move it to the other side, it will divide by this 4. When we will divide, we will get the decimal value, or you can simply leave it in the form of fraction as well. Let's substitute this back in the original equation so we can find the connecting equations. So the connecting equation will be y is equals to 21 upon 4 x square. This is my connecting equation. Now what they're asking, they're saying find the value of y when x is equals to 4. We have to find the value of y using this connecting equation. Y is equals to 21 upon 4 x square and x is 4 over here. So what I'm going to do, y is equals to 21 upon 4 multiplied by 4 square. Okay, so this over here is, you can cancel it out since there are 4 over here, 4 square now. So I can simply cut this value, this 4 and this power, because there are 2 4s, 4 into 4. So 1 4 is simply cancelled by this denominator. So we have only one value of 4 over here. Y is equals to 21 multiplied by 4. Simplify this one, 21 multiplied by 4. 4 1s are 4, 4 2s are 8. So 84 is the value of y over here. Okay, now let's solve part 3 as well. Given that k is directly proportional to h square, h is a positive real number, copy and complete the table, and one table is given to us in which we have different values of h and different values of k. Let's just solve this line by line. First we are going to focus on this. Y is directly proportional to h square, k is directly proportional to h square. So I am going to convert this. K is directly proportional to h square. Now have you observed that they have already given us the variable k. So we cannot take the constant value when we remove the proportionality sign. So we use the constant that is usually k. Now we have to use any other variable instead of k because k is already given in the question. So I am going to remove this sign of proportionality and I am going to introduce any other variable. Let's suppose I'm saying I will choose this variable a over here. Now this a is the constant over here. Clear? And we are required to find the value of this a. So how are we going to find the value of this k? In the table we are going to take a pair of value. If you can observe that this is the pair of value where h is 3 and k is 81. Using this value, this set of value, I can find the value of a over here. So k is 81 is equals to a. H is 3 square. 3 square is again 9. So 81 is equals to 9a. Since we need to find the value of a, so I have to isolate this a. This 9 is multiplying with this a. When I will move it to the other side, it will divide. So a is equals to 9. 9 is 81. So a is equals to 9. Now put this value again over here. So we will find the connecting equation. K is equals to 9h square. this is my connecting equation. Now using this connecting equation, I am going to find all the missing values. Okay, now use this connecting equation. K is equals to 9h square. From the table you can observe that h is equals to 2. So what will be the value of k over here? So h is equals to 2. Let's see, k is equals to 9h is 2 square. 2 2s are 4, so k is equals to 9 into 4 and k is equals to 36. The first value over here will come as 36. Second is k is equals to 56.25 given to us. So let's see, k is equals to 56.25 and the connecting equation is k is equals to 9h square. So I'm substituting this value over here in the place of k. 56.25 is equals to 9h square. Now I need to find the value of h. This 9 is multiplying over here. When I will move it to the other side, it will divide by this 9. By this 9 h square. So 9 ones are 9. 9 6 are 9 6 are 54. So 54. 2 is remaining in 56. So I have written this 2 over here. Now we're solving after the decimal na. So 9 2s are 18. Then 19 20 21 22. 4 is remaining, so I will write this 4 over here and 9 5s are 45. So h square is equals to 6.25. This is the value of h square and where we have to find the value of single h. So what I'm going to do, I'm going to taking root on both sides. Since root is the opposite, when we want to remove the square, now we will take root on both sides. So h square is equals to 6.25. Now taking this decimal square root is quite difficult. So what I'm going to do, I'm going to remove this decimal from here. Now I'm going to move this decimal towards these two places. So whenever this square and root is cancelled, this is single h. Now solve this. Whenever when we move the root to decimal to the other places, now it will be like this: 625 upon 100. Because I have moved decimal 2 places to the right, so I have to introduce 2 zeros in the denominator to cancel the effect. Is that clear? Now how we are going to find the root? It is written h is equals to under root 625 upon under root 100. I have distributed the root to numerator and denominator, and that is completely okay. Now I'm going to do 625 is the perfect square of 25. So I can write 25 square over here, and 100 is a perfect square of 10. So I can write 10 square over here. Okay, 25 25s are 625 and 100 10 10s are 100. So square and root will be cancelled out. Square and root will be cancelled out. H is equals to 25 upon 10 and h is equals to 2.5. So the value over here in the table will be 2.5. Two remaining values over here that we have to find when h is equals to 5. When h is equals to 5, using the same connecting equation, k is equals to 9h square and k is equals to 9 into 5 square. 5 square is 25. So 9 multiplied by 25 over here. Okay, and this will be k is equals to 225. K is equals to 225. 225. One last value over here we have to find. When k is equals to 441 is given, we have to find h. Using the same connecting equation, the connecting equation is k is equals to 9h square. And value of k is given to us, that is 441 is equals to 9h square. So this 9 is multiplying by this h square. When I will move it to the other side, it will divide. Is equals to h square. So 9 4s are 36 and 37 38 39 40 41 42 43 44 81 and 9 9s are 81. So h square is equals to 49. We have to get rid of this square as well, so taking root on both sides, under roots 49. 49 is the perfect square of 7. 7 sevens are 49, so h is equals to 7 is the answer. H is 7 is the answer. Okay, so this is the required values of the table.